Hey, party people! People who love to party! It's me, Mr. Beal, here to talk to you today about trigonometric ratios. Now, if you've ever heard the word trigonometry or trig, it refers to triangles. Specifically, right triangles are what we build that study of triangles with. And the first thing that we need to do in learning trigonometry is being able to have perspective from a specific angle. So as you take this bad boy out, you'll see that there's a whole bunch of missing stuff from these triangles, and all it says up top is name the opposite and adjacent side for each angle, also name the hypotenuse. So you've got three things to name on each triangle, and the idea is those things are all relative to A. Here is A right here. Now the other thing we need to put in here is obviously our right angles so that we know that these are right triangles. And I know this probably bugs you. You're like, why do you not just put them on the worksheet, Mr. Beal? Because you must do these worksheets along with the videos, not just watch the video. Watching the video doesn't make you proficient. Doing the action is what's going to make you proficient, and then practicing. We got to practice. I've got all my right angles in. We are going from this perspective. We're going from A, and we want to know what side is opposite from angle A. Now, the word opposite, you probably know just fine. So you're like, opposite, so like on the other side of? Absolutely. So the opposite side to A in this is right here. There's the opposite side. And you'll see that I've abbreviated it because I'm lazy. After that, the adjacent side. Now this and the hypotenuse, a little dicey. Adjacent means next to, is touching and next to. So if we're looking at A, you're like, well, it's got two that are touching and next to. That's true, but only one of those can be the hypotenuse. And the hypotenuse is the longest one or the one across from the right angle. So if I'm looking for just the one that's touching it, but not the longest one that's next to the right angle, here is the adjacent side. Bam. Touching it is not opposite the right angle, is not the longest side. Hypotenuse, longest side. Well, that only leaves us with one left, and that's right here. This thing right here has to be the hypotenuse. Once again, abbreviated by me. Perfect. Your job is to do that for the rest of the triangles on this paper and then check in with me. So do not just wait for me to do it for you. Do it right now. I'll even pause it. I'm going to pause it. You're going to do it. That's what it's going to work. Did you do it? Good, because you were supposed to pause and do it. All right, let's take a look at what we've got. Bam. Ooh, look at all my crazy scribbly looking writing. Over here, opposite of B would be this side right there. This is the adjacent side. That's the hypotenuse. I'm expecting you guys to get the opposite one right immediately. It's the farthest one way over. It's the adjacent and the hypotenuse. Getting those straight is going to be the big deal. So if you did that one right, good job. All right, there's the next two. Ooh, look at those. Yeah. So you've got the opposite side from C, the adjacent side, the hypotenuse. Over here, Q is the angle that we're going from. I only named one angle for you to go from. So Q, there's the opposite, adjacent, and hypotenuse. If we were going from this, our opposite and adjacent would have switched sides. Did you realize that? But you didn't. All right, and then the last two. This one right here, we've got opposite, adjacent, hypotenuse. This guy, though, I expect you did something like this. Well, this side is the hypotenuse, but it's also the opposite. And we've got two adjacent sides. Or maybe you did something like this. Question mark, sad face. I don't know, but that's basically what happens here. We're not talking about that 90-degree angle. It's not that trigonometry doesn't work with 90-degree angles. It certainly does. We can find values for that. But because of this weird scenario that we get here where we can't identify which one is the adjacent and the opposite and the hypotenuse are the same, we get some weird stuff out of that, and we're not dealing with that case right now. We're just going to be sticking with these two angles from now on. So take your paper, take the other side of it. If it double printed like sometimes my printer does, it makes me mad, then you're just going to flip it over. And if you were able to print two separate pages like I would prefer my printer to do, which it doesn't, then here you go. Why is this important? Well, from the idea of perspective, we can get our trigonometric ratios. And we've got three of them: sine, cosine, and tangent. For sine, the way that we make this ratio, first of all, we write sine of an angle, and the generic angle to use is theta. That's a Greek letter, theta. So if you move on and you join a frat and it has a theta in it, you learn that from me. Now be a decent human being. See, and this is an angle. That's going on there. We're putting an angle there. The sine of whatever angle we pick is always going to be the opposite side over the hypotenuse. So it's a way in triangles to link their sides to their angles. Ooh, ghosts. The way it would work in this one, let's say we choose L. Let's just deal with angle L. If I were to take the sine of L, that would be my opposite side, which is JG, over my hypotenuse, which looks like it's LG. Our cosine, we abbreviated it to just COS, just like this was abbreviated SIN. This gets COS, but we still say cosine. You're going to walk up to me and you're going to say cos, and that's going to make me mad. This cosine is equal to the adjacent over the hypotenuse. So let's work with cosine. Cosine of L would be, see, your adjacent side is this one down here, JL, over LG. That's still the hypotenuse. Nothing has changed. And lastly, tangent. Tangent is the one I like the least. And it's also the one that books sometimes like to teach first, and that makes me super mad. Tangent of theta, remember that's just an angle, is equal to the adjacent side, the opposite side, I'm writing down the word opposite, over adjacent. So in this case, tangent of L, our angle L, bam, I want the opposite, JG, over my adjacent, JL. Now, if you look at that and you see alphabet soup, Mr. B, I'll just see a bunch of letters. That's not helpful. I hate you. I understand. You need to stop telling me that you hate me, though. It's rude. I'm going to actually do this from the tangent, and I'm going to throw some numbers in here. We're going to make this a 2. We're going to make this a 7. Oh, wait a second. No. This would be 7. There we go. And then this will be, let me think, 3 root 5. Now let's make sure. Let's use a Pythagorean theorem and check. 2 squared plus 3 root 5 squared is equal to 7 squared. That'd be 49. This would be 4 plus 3 times 3 makes 9. Root 5 times root 5 makes 5. So that'd be 4 plus 45 is equal to 49. Huh. That's true. So if I want the sine, the tangent of L, that's going to be equal to JG 2 over JL 3 root 5. We're not allowed to have a root on the bottom. So you have to reduce. You have to, in this case, rationalize the denominator. All the rules that normally follow for fractions, you have to do with these. So this would be equal to, let's see, times root 5 times root 5. I've got 2 root 5 over 3 times 5. Well, that's 15. I'll put like a little break in there. 3 times 5, bam, and then back to the 15. That way it's written there. That way you guys don't freak out. Let's try it again on cosine. My cosine of L, and from this angle, I'm going to go here, 3 root 5 over 7. 3 root 5 over 7. Ms. Beal, do I have to multiply by root 5 this time? No, there's no denominator to rationalize. And they don't reduce. We're good to go. That's all we had to do. It's great. Then sine L is equal to JG. That's 2 over LJ, which is 7. Once again, doesn't reduce, super easy. That's how these work. This is the whole ratio, the whole thing. And you guys, that looks terrible. Hold on. Tangent of L is equal to 2 root 5 over 15. And you guys, if you're writing the ratio, you have to write the whole thing out. You write it out as an equation. That's your whole answer. as you look to the work that you're going to do on this, because you're going to be working with these triangles, you are just going to write the fraction. But if we were working on a problem and I wanted to know this whole thing, you'd write the whole thing out. Notice how these things have equal sign and they're just ready for the fraction. You need to write the whole thing because our next lesson that's going to be super important for and the one after that. So try these problems. We will come back and there will be answers there. And hopefully you'll be happy. And we're back again. That wasn't very long for me. I hope it wasn't too long for you. I hope it went well. Let's find out because this is going to be key to us doing these problems right in the future. Bam. Ooh, take a look at my answers. So 1, you got 3/5. Probably should have gone 1, 2, 3 down this way. 4 is 4/5. And then this, look at cosine B and sine of A. They have the same ratio. Isn't that crazy? Even though they're two different angles. It's a triangle. There's only so many sides. Over here, you got 7/24, 24/25, and 7/25. And then finally, over here, whoop, with 3, you ended up with 6/2√10. For sure. This should have been the right angles. Geez, I didn't even do the right angles this time. What a chump. Or up here. Aggravating. Okay, but back to here. 6/2√10. The 2 and the 6 can cancel out. I've got 3/√10. Then I'm going to times by √10 on both the top and the bottom to get 3√10/10. Ding. Tangent of I is 2/6, which is 1/3. We reduce it. You got to reduce. All the rules for fractions apply. And then this last one, the sine G was the same as cosine I. So I got to skip ahead because I already knew what that was. Guys, if you have any questions on this, please feel free to ask me. If you are confused, don't stay confused. Reach out to me some sort of way. Whatever way works and whatever time we're in. That's it for this lesson. Stay safe. Roll crazy.